Here, in the sun-dappled savanna of classification, reigns the logistic regression lion, a king of the linear kingdom. He hunts for relationships between features, separating prey into neat categories with a single, decisive bite. His roar is the sound of a perfectly placed decision boundary, and his reign is one of order and predictability. But the jungle is not all savanna. In the dappled shadows of clustering, the K-means chameleon reigns supreme, a master of adaptation. He blends seamlessly into groups, identifying patterns in the chaos of data. Watch as he shifts his colors, finding kinship with each cluster, and bringing order to the unlabeled masses. Deep within the tangled thicket of decision trees, the random forest rangers patrol. These agile squirrels, armed with a quiver of questions, navigate the undergrowth with precision. Each ranger, a single tree, asks a simple question, splitting the data like a fallen log together. They form a labyrinthine network, leading to the hidden treasures of insight. But the true apex predator of this jungle is the deep learning dragon, a creature of immense power. His scales are layers of interconnected neurons. His breath a firestorm of calculations. He devours data whole, extracting meaning from the most complex patterns. His wings casting a shadow over the entire ecosystem. Yet, the jungle is not a battleground. Here, even the fiercest predators rely on symbiosis. The logistic lion's classifications provide training data for the deep learning dragon. The K-means chameleon's clusters guide the random forest rangers. Each algorithm, a unique species, plays a vital role in the grand symphony of machine learning.
Imagine you're building a house. Would you use a hammer for every task? Of course not. You need saws for cutting, screwdrivers for assembly, and maybe even a paintbrush for decoration. Just like building a house, solving data challenges in AI requires the right tool for the job. Welcome to the workshop of AI. Today, we're debunking the myth that neural networks are the ultimate tool for every data problem. While they're powerful, they're just one member of a diverse toolbox. Neural networks are the rock stars of AI. They excel at complex tasks like image recognition and language translation, learning intricate patterns from massive amounts of data. But just like a rock star wouldn't be your go-to plumber, neural networks aren't the answer to everything. Sometimes, a simple tool does the job best. Imagine needing to sort laundry. Would you train a complex neural network, or just use a basic sorting algorithm based on color or type? For straightforward tasks, simpler algorithms like decision trees or linear regression are often faster, more efficient, and easier to understand. Let's say you're doing laundry, and your favorite sock disappears. You might use a supervised learning algorithm, like a decision tree, to solve this mystery. It's like training a detective with labeled clues. Is the sock clean? Is it striped? Did you check the dryer vent? By following these decision branches, the algorithm narrows down the suspects, bringing your sock back from the laundry purgatory. But what if you don't know what you're looking for? That's where unsupervised learning comes in. Imagine a curious cat exploring a new garden. It sniffs and swats, trying to make sense of the unfamiliar smells and textures. Similarly, algorithms like K-means clustering can group data points based on hidden patterns, even without labels. Like the cat discovering flower families, K-means might find clusters of customers who like similar products, helping you target your marketing meowgically. Now, let's say you want to learn how to cook the perfect omelette. You wouldn't just grab a bunch of ingredients and hope for the best. You'd need reinforcement learning. This algorithm is like a master chef, learning from trial and error. Every flip, every fold, every burnt patch tells it what works and what doesn't. With each attempt, it refines its recipe, eventually whipping up a culinary masterpiece. But the beauty of AI lies in its diversity. Just like an orchestra needs different instruments to create harmony, different algorithms excel at different tasks. Supervised learning for classification, unsupervised for exploration, and reinforcement for mastering skills. They all play crucial roles in the symphony of AI, each adding its unique melody to the overall composition. Just like each tool in a carpenter's kit has its purpose, different algorithms excel at different things. Logistic regression shines at classification, while K-means clustering groups similar data points. Choosing the right tool depends on the nature of your data and the question you're trying to answer. The beauty of AI lies in its versatility. Different algorithms often work together, like instruments in an orchestra, to achieve a unified goal. Neural networks might extract hidden features, while simpler algorithms interpret and explain them. By combining their strengths, we unlock a more comprehensive understanding of the data. So, the next time you hear about AI, remember, it's not just about neural networks. It's a symphony of algorithms, each playing its unique role in the quest for knowledge. And by choosing the right tool for the job, we can build solutions that are not only powerful, but also efficient, transparent, and adaptable. While neural networks are impressive, they're just one piece of the AI puzzle. Understanding the strengths and limitations of different algorithms is key to unlocking the full potential of this exciting field. So, explore the AI toolbox, discover its diverse tools, and become a master builder of solutions, not just a hammer-wielding enthusiast.
Artificial intelligence and machine learning are all the rage, promising to revolutionize every corner of our lives. But amidst the hype, a crucial question emerges: is a neural network always the answer? Today, we explore real-world scenarios where AI shines, but surprisingly, not through the lens of complex networks. Imagine a bank assessing loan applications. Would they throw a neural network at the mountains of financial data? Not quite. Here, decision trees, with their clear-cut branching logic, take center stage. Each branch asks a simple question: income level, credit score, employment history, and guides the application towards approval or denial. Transparent, interpretable, and efficient. Decision trees provide the bank with a reliable risk assessment, without the black box complexity of a neural network. Now, step into a bustling factory. Here, maximizing production while minimizing energy consumption is critical. Enter linear regression, the master of finding linear relationships by analyzing data on machine performance, energy usage, and output. Linear regression can fine-tune production cycles, predict maintenance needs, and optimize energy use, all with a simple, understandable formula. No need for the heavy computational firepower of a neural network here, just straightforward calculations, leading to significant efficiency gains. Ever drowning in spam emails? Neural networks can help, but simpler solutions often win the day. Spam filters rely on powerful rule-based algorithms that identify suspicious patterns, words, sender addresses, suspicious links with remarkable accuracy. These rules are constantly updated, evolving alongside spam tactics, offering a nimble and efficient defense against ever-changing threats. While neural networks hold promise for future spam detection, for now, simple rules often pack the biggest punch. Moving to the realm of healthcare, AI plays a crucial role in analyzing medical images and patient data. However, neural networks alone can be risky in critical diagnosis. Transparency and interpretability are paramount. Here, AI often takes a supportive role, assisting doctors by highlighting anomalies, flagging potential risks, and providing additional data points. The final decision, however, rests with the physician, leveraging their expertise and knowledge alongside the insights of AI. So, remember, AI is not just about neural networks. It's a diverse toolkit, and different problems demand different tools. From the clear logic of decision trees to the efficient calculations of linear regression, the right algorithm can unlock tremendous value, without the need for overwhelming complexity. So, next time you encounter AI, look beyond the hype and delve deeper. You might be surprised by the diverse array of tools silently shaping our world, often without the fanfare of their more flamboyant counterparts. AI is a powerful tool, but understanding its nuances is key. Choosing the right algorithm for the task, even if it's not a neural network, paves the way for responsible, effective, and impactful solutions that truly move the needle.